Hello everyone. So we are going to talk about the section 4.2 today, which is about the definition of trigonometric function. And in this problem number 3, we are you just have to find the value of the trigonometric functions of the angle in standard position whose terminal side passes through the given point. So in this problem number 3, you have the point right here. You have this point right there. X equals 6 and y equal 8. And you have to find the value of cosinus, of sinus, tangent, cosecant, secant, and cotangent. What do we do for that? First of all, you need to represent on your Cartesian system coordinate, plot the point 6, 8, define the terminal side as I did, and look at what is the cosinus of the angle theta, knowing that the angle theta is in between the initial side and the terminal side. So the cosinus of an angle is equal to the adjacent side, which is x over r. And we know x because x equals 6. We don't know r, but to calculate r, we need to look at the triangle A, B, and C. And in this right triangle, we apply the Pythagorean theorem. When I am applying the Pythagorean theorem, which is the sum of the square of each leg is equal to the square of the hypotenuse, and the hypotenuse is r. So r will be equal to the square root of y squared plus x squared, which when I calculate with the value of x and y that I'm dealing with, whether it's a 6, we end up to have r equal 10. Therefore, my cosinus will be x over r, which is 6 over 10. My sinus, which is y over r, which will be 8 over 10. Now, for my tangent, it's y over x, it will be 8 over 6, pretty easy. For my cosec, which is the inverse of sinus, I will end up with a 10 over 8. My secant, which is the inverse of cosinus, this time it's r over x, which is 10 over 6. And the cotangent, it is 6 over 8 because it's the inverse of tangent, which is the inverse of tangent being x over y. Problem number 7 is exactly the same thing, but this time you are dealing with 2 points. One is 0.09, which is 9 divided by 100, and they are giving you 0.40. Some of you may think that it could be 4 divided by 10, but they are giving you 40 because it's 40 divided by 100. By doing that, when you are going to calculate the value of r through the Pythagorean theorem, you will end up to have 41 over 100. If you are using x equal 9 divided by 100 and y equal 4 divided by 10, you are going to end up to deal with a value of your hypotenuse much more complicated, because instead to have the square root of 10,000, you will have to calculate the square root of 10,100, and that is not it's not very easy to deal with. It will give you a decimal number. So now we have r. We can do exactly what we have done previously. Cosinus of my angle is going to be 9 over 100 divided by my r. I flip my second fraction, and now I end up to have 9 over 41. For the sinus, same idea. I flip the seconds. Don't forget, when you are converting the main fraction bar right here into a multiplication, the second fraction, the fraction below, the fraction on your denominator will be flipped, and so you end up to have 4 over 41. Same thing for the value of tangent, which is going to end up to be 40 over 9. The cosec will end up to be 41 over 4. The secant, 41 over 9. And finally, the cotangent, which is going to be 9 over 4. Take your time. You can always make a pause. And now we are going to continue trying to do the problem number 9. What do we have to do with problem number 9? It's 1.2 and 3.5 for the value of x and r, x and y. I'll let you do this one by yourself. It's pretty easy. It's the same idea. You are going to end up basically with 12 divided by 10 for the value of x. So let me at least give you for the problem number 9, when you have x equal 1.2 and y equal 3.5, it's, I think, the best way to deal with that is to have 12 over 10 and 35 divided by 10. Let's try to do now problem number 15. So what do we have with the problem number 15? We end up to have 50 and 20, same idea, x equal 50 and y equal 20. So I'll let you do this one also. And I would like to move on to the problem number 17 is same idea, number 29. So what do we have in this problem number 29? Each given point is on the terminal. Okay guys, so now on this problem number 29, we have the first point 0.3 and 0.1. Oops, and a point 0.1, which I would transform into the point 3 out of 3 divided by 10 and 1 divided by 10. And we have the point 9.3, and we have the third point 33 and 11. 33 for x and 11 for y. And we have to calculate the tangent of the angle and the secant of the angle. I'd like to remind you the purpose of this problem. Each given point is on the terminal side and of an angle, show that each of the given function is the same for each point. So let's try to calculate the tangent of the angle theta. So if I'm going to call the point number 1, number 2, and point number 3, I'm going to calculate the tangent for the point number 1, the tangent for the point number 1. So let's put that for the point number 1. What do we have? And we have y divided by x, which is supposed to be 1 over 10 divided by 3 over 10. Like I did in the previous problem, I'm going to flip my denominator, which is going to be 10 divided by 3. So my answer is going to be 1/3. If I'm calculating the tangent theta for the point number 2, I will have a tangent theta equal to y divided by x again, and this time I end up to have a 3 over 9, which simplified to 1/3. And the last point, for the point number 3, the tangent of my angle is going to be 33, oops, no, see, that's why I think it's very important to rewrite y divided by x. So it's going to be 11 over 33. And I can clearly, which is pretty close to 1/3. If I do the calculation, and you will forgive me if I'm using my calculator, 11 divided by 33, it is 0.33. So it's really, really close to, actually it is exactly the same thing, 1/3. So yes, it is correct. Now if I try to calculate the secant, so if I calculate the secant for the point number 1, the value of secant is the inverse of cosinus. And so obviously I will have to calculate the value of r. So the secant is the inverse of cosinus, which is x over r, which is r over x. So I will have to calculate every single time r over x and r over x. So I am going to calculate for each of my points right here. I'm going to choose another color, the value of r, which is the square root of x squared plus y squared using the Pythagorean theorem. So in that case, it's going to be 3 out of 10 square, and I'm taking everything, plus 1 out of 10 square. Therefore, I end up to have the square root of 9 plus 1, so 9 over 100 plus 1 over 100, which is the square root of 10 divided by 100, which is going to be 1 over the square root of 10. for the second point, I'm going to have a r equal to the square root of 9 square plus 3 square, which is the square root of 81 plus 9, which is the square root of 90. And the square root of 90, if I want to simplify, it is the square root of 9 multiplied by 10, which is the square root of 9 multiplied by the square root of 10. And so I end up to have a 3 square root of 10. Finally, for the last one, the value of r is going to be the square root of 33 square plus 11 square. And so it's going to be a 33 square. What is 33 square? 33 square. So 33 square plus 11 square. And if I take the square root of that, so it's going to be the square root of 1210. And if I take the square root of this, hopefully it will be an easy square. No, it's not. So it's going to be the square root of 1210. So when I'm going to calculate the secant of that angle, it's going to be the 1 over square root of 10 divided by x. And x is 3 over 10. 3 divided by 10. So that gives me a 1 over square root of 10 multiplied by 10 over 3. And so the answer is going to be basically 10 over 3 times square root of 10. If I look at the second one, r, we said would be 3 square root of 10. So I'm having right here a 3 square root of 10 over x, and I know that my x equals 9. So it's going to be a square root of 10 divided by 3 on this side. And if I look at the last one, I end up to have a r, which is the square root of 1210 divided by x, and x is supposed to be 33. So let's go back a little bit on the first one. When you have 10 over 3, so let's calculate, let's see if I can calculate the decimal. So I'm going to calculate the last one because that's the one I have on my calculator. Divided by 33, I think I found one around 1.05409. On this one, I end up to have the square root of 10 divided by 3. Oops, I need to put my parentheses. Divided by 3, and I get 1.05409. And the last one, 10 divided by 3 times, and I bet it's going to be exactly the same thing, right? The 3 times the square root of 10. And I end up to have 1.0540. So yes, I do have exactly the same thing I'm looking for. All right, guys, I'm arriving almost at the end of this first video. That will be the part 1 of the section 4.2, and I will try to finish all the other problem. Actually, I have to finish problem number 33. And if the angle intersects the unit circle exactly at 0.28, 0.96, find the sinus and cosecant. So basically, it's exactly the same thing that we done previously. I'm going to write the answer and go back to the video. Alright guys, so when you look at the problem number 33, the first thing you will have to do is calculate the value of r by using the Pythagorean theorem. When you do the calculation, you will find 1, and then you will just have to calculate the sinus and the cosecant. Sinus being y over r and cosecant being the inverse of your sinus, and this will be the answer of your questions. So thank you very much, and I will try to pause that video and try to do another one for you. Thank you, and talk to you very soon.